Welcome to BCMSN Lab number 3. In Lab number 3, our focus is on redundancy. If we have a couple of routers that will get us out, let's say to a backbone network, and one of those routers were to go down, or an interface on one of those routers were to go down, could we reroute through that other backup router? And the answer is probably yes, if we're talking about another router rerouting across that backup router, because that's what routing protocols can do for us. They can help us learn an alternate path to get to a destination network. However, what if we're talking about this from the perspective of a PC? Think of a PC on a user's desktop. Their PC has a configuration for a default gateway. In other words, an IP address to which that PC sends all packets outside of its local subnet. Typically, this is the IP address of a router interface. But here's the challenge. If that router or that router interface goes down, could that PC continuing to point to that same IP address still reroute across the backup router? That's what HSRP can help us out with. We're going to begin Lab number 3 with a review of how HSRP operates. HSRP, that's Cisco's proprietary hot standby router protocol. We're going to see how to configure HSRP with just a couple of basic configuration commands, and we're going to verify HSRP operation with a show command. Then we are going to watch HSRP in action by simulating a failure. We will unplug the cable going into the Ethernet interface on one of our routers to simulate an interface failure or a router failure, and we can see that HSRP, after just a few seconds, is going to cut over to the backup router. And by watching that happen, we're going to be able to make a couple of observations. There may be a couple of things with HSRP that we want to go in and influence. We're going to tune HSRP with a couple of commands, and then we're going to verify the effects of that tuning. But let's begin by reviewing what HSRP can do for us. This is the topology we're going to be working with. I have a router acting as a PC. In other words, IP routing is disabled on that router that's named PC. Instead, we're going to use the command IP default-gateway to point to the default gateway. But the question is, am I going to be pointing to the IP address of router R1's Ethernet interface, or am I going to be pointing to the IP address of router R2's Ethernet interface? And the answer is neither. We're going to point to a completely different IP address, because HSRP is going to allow router R1 and router R2 to maintain the IP address for a virtual router. This virtual router, sometimes we call it a phantom router, in this case is going to have an IP address of 10.1.1.100. That's the default gateway IP address that we're going to point our PC router to. However, even though either router R1 or router R2 could service requests destined for that IP address, only one router at a time will be active and actually forwarding those packets. As we begin, we want to influence router R1 to be the active router. It's going to be handling those packets, and router R2 is going to be the standby router. So when the PC sends traffic up to the backbone network, 192.168.1.1, that's the specific IP address that we'll be pinging, the traffic will initially go through router R1. Then we will simulate a failure scenario. I will unplug the cable from R1's Ethernet 0 interface. After we do that, after just a few seconds elapse, we will notice that router R2 has taken over and we're still forwarding packets to the backbone network. Router R2 has now become active and packets are flowing through router R2. Let's see the syntax to make this happen. First of all, on the router that's acting as the PC, we need to point it to a default gateway. We can do that with the command in global configuration mode, IP default-gateway followed by the IP address. And in our instance, that IP address is going to be 10.1.1.100. And again, this can specify a next hop gateway when routing is disabled. And then we'll go over to router R1 and issue the standby command. We can say standby followed by a group number, followed by the keyword of IP, followed by the IP address. And this IP address, that's the virtual IP address we were speaking of. This same command will also be given on router R2. They will both be maintaining the same virtual IP address. but we wish to influence which router is going to be the active router to begin with. We want router R1 to be that active router. We can make that happen by giving this command: standby, followed by that same group number, followed by the keyword of priority, followed by a number. By default, these routers have a default priority of 100. So if I want to influence router R1 to become the active router, I can use this command to say that it has a priority that is greater than 100. Let's now go out to the router interface and set this up. Let's begin on our PC router. On the PC router, let's go into global configuration mode and say we want to configure a default gateway of 10.1.1.100. We do that with the command IP default gateway 10.1.1.100. At this point, let's go to routers R1 and R2 and set up HSRP, beginning over on router R1. On router R1, let's first of all go into interface configuration mode for interface Ethernet 0, and we give the standby command. We say standby, we give the HSRP group number, which is just 1 in this case, just a number we make up. We give the keyword of IP followed by the IP address of the virtual router. This is the IP address that our PC, which is a router in our topology, that our PC is pointing to. One extra thing we want to do on router R1, we want to influence this to become the active router. We're going to say standby, giving that same HSRP group number again, and we give the keyword of priority. We say priority 150. Remember, the default priority is 100. If we want to influence router R1 to become the default active gateway, we want to specify that it has a priority of something greater than 100. So we statically set that to 150. And as we go over to router R2, remember that we will not need to do this on router R2. On router R2, we simply need to go into interface configuration mode for interface Ethernet 0 and say standby 1 IP followed by that IP address. And we can leave this interface at its default priority of 100. Let's see how HSRP is currently functioning. We can give the show standby command and notice a few things. First of all, we can see that we are currently in the listen state. Something that happens with HSRP as we enable HSRP on our router, HSRP transitions through various states. We start off with the state of initial. This is where HSRP is not even running. Then we go into the listen state like we see here on the screen. This is where HSRP is aware of the virtual IP address, but it's just listening at this point to hello messages in an attempt to find its place in the network. And the hello message, that's what helps the standby and active routers to learn who is the active and who is the standby router. And when the standby router has not heard a hello for a period of time, we call this the hold time, the standby router realizes that the active router must have gone down, and the standby router transitions and becomes the active router. After we leave the listen state, HSRP enters the speak state. In the speak state, it starts to send hello messages and it participates in the HSRP election. And depending on the results of that election, maybe this router becomes the standby router, or perhaps this router becomes the active router. In this case, we're going to become the standby router. Let's verify that. Let's say show standby once more. We should have transitioned through all of our states, and notice that now we are in the standby state. Something else to notice is the virtual IP address. This is the IP address that we are servicing on this router. We also have not just a virtual layer 3 IP address, we also need to have a virtual layer 2 MAC address. And we did not configure this MAC address. This was automatically generated by HSRP. And here's how we can know that. First of all, if we break down that 48-bit MAC address, which is written here in hexadecimal notation, the 0000.0c, that's one of Cisco's well-known vendor codes. We know that this MAC address is a Cisco MAC address. The next portion of the MAC address, 07.ac, that's what Cisco uses internally to indicate that this is an HSRP MAC address. finally, the last two hexadecimal digits, that's the HSRP group number written in hexadecimal notation. In our case, we had a decimal HSRP group number of 1, which is simply a 01 in hex. We talked about the timers. Here we see what we are defaulting to for our hello and hold time timers. The hello time is 3 seconds. In other words, every 3 seconds, we're going to be sending a hello message. And if the standby router has not heard a hello message from the active router within a period of 10 seconds in this case, the whole time, the standby router is going to conclude that the active router must have gone down, and the standby router is going to transition to the active router. We can also see the IP address of the active router. It's router R1 at an IP address of 10.1.1.1. We see that it has a priority of 150, and we see that our local priority is only 100. Let's do this. Let's go over to our PC router once again and start a ping. Let's send a series of pings over to that backbone IP address. Let's get back over to router PC, and let's do an extended ping using the IP protocol using a target address of 192.168.1.1, and we will send multiple pings so we can watch this as it happens. Let's go ahead and start this series of pings, and I'm going to go over, and on the count of 3, I'm going to unplug the cable from router R1's Ethernet 0 interface, and we will notice that the pings do stop. 1, 2, 3. I've unplugged the cable. Let's watch what happens. We wait a few seconds, and after the hold time timer expires, notice that the pings resume. We have failed over to our backup path at this point. Now, let's restore the connection. I'm going to reconnect the cable into the Ethernet port, and let's go over to router R1, and I think we may see something that's a bit surprising at this point. On router R1, if we issue a show standby command, notice this. Notice that the active router is 10.1.1.2. That's router R2, and it only has a priority of 100 while we have a priority of 150. Why are we not the active router? Let's consider that. The topology on screen represents what we were witnessing when we had unplugged the cable from R1's Ethernet 0 interface. R1 was down, traffic began to flow through router R2. However, here's what we noticed. Even after our primary connection was restored, the connection that we preferred to use, traffic continued to flow through the backup router, through router R2. What we want to do now is configure router R1 so that if it has an outage after it recovers from that outage, we want router R1 to transition back to the active router, which is going to force router R2 back to the standby router, and we want traffic once again to flow through router R1. Let's see the syntax to make that happen. Here's what we're going to do. We're going to go into router R1's Ethernet 0 interface and add the command standby followed by our HSRP group number followed by the keyword of preempt. This is going to tell HSRP that this router should be able to get its old job back if it recovers from an outage. We're going to preempt an existing active router and take over once again. We may also want to tune the HSRP timers. Remember when we gave the show standby command? We had a hello timer of 3 seconds and a hold time timer of 10 seconds. And Cisco recommends that the hold time be at least 3 times the hello time. Let's say that we want this cutover to happen even more quickly. We can manipulate those timers. We can make them smaller. We can make them larger. What we're going to do in this lab is we're going to reduce the hello time down to a single second, and the hold time we will reduce to 3 seconds. Let's go back out and set this up. On router R1, let's get back into interface configuration mode for interface Ethernet 0 and tell router R1 that it can regain its previous role as the active router if it recovers from an outage. We do that with the command standby 1, that's our HSRP group number, followed by the keyword of preempt. Something else we said we wanted to modify had to do with the timers. Let's say standby 1 timers, and let's make the hello timer 1 second and the hold time timer 3 seconds. Since we want our timers to match on both routers, let's move back over to router R2 and give that timers command on router R2. We get back into interface configuration mode for Ethernet 0 and we say standby 1, timers 1, 3. At this point, I think we're ready to test HSRP again. From router R2, let's first verify that router R1 is the active router since we've given that preempt command on router R1. We can issue the show standby command. Sure enough, the active router is 10.1.1.1. That's router R1. Let's move back over to our PC router and start that extended ping once again. From the PC router, let's do an extended ping to IP address 192.168.1.1. We'll send a large number of pings. And once again, on the count of 3, I'm going to unplug the cable from R1's Ethernet 0 interface. 1, 2, 3. We see the ping stop and then very quickly return after only about 3 seconds. This is much quicker than we previously experienced. Now let me plug the cable back in so we can cut back over to router R1 as our active router, and let's verify that router R1 is indeed our active router. Let's go over to router R1 and let's issue the show standby command. And we will notice that the active router is local. It's us, it's router R1. And the standby router, once again, is router R2. And as a best practice, we should go to all of our routers and copy the running configuration to the startup configuration. Let's review where we have been in this lab. In BCMSN lab number 3, we took a look at how HSRP, the hot standby router protocol, could help provide redundancy, perhaps for a PC, pointing to a default gateway. We reviewed the operation of HSRP. We took a look at the configuration commands to set it up. We used a series of standby commands. We verified HSRP operation with the show standby command, and we even simulated a failure by unplugging a cable from router R1's Ethernet interface. But we made an observation that when we recovered from that outage, router R1 by default did not take back its role as the active router. Instead, it became the standby router. We said that we might want to change that so that router R1 could regain its active status after recovering from an outage. We saw the syntax to set that up, and we also talked about the syntax to adjust the timers that HSRP uses. The hello time timer and the hold time timer. We reduced those values so that we could cut over more quickly. And we verified our configuration by simulating a failure once again. This time the cutover happened after only about 3 seconds. And when we recovered from that outage, because we had used the preempt option, router R1 once again became the active HSRP router.